Hello and welcome to the YouTube channel D Creations Resources. We are looking at different concepts from science. In the earlier episodes, we spoke about Hall effect. Then we also spoke about drift velocity. And while talking about drift velocity, a concept was mentioned, the concept of mobility. So let's talk about mobility here. The context of physics and specifically electrical conductivity. So mobility, which is usually denoted as mu, refers to how easily a charged particle can move through a material in response to an electric field. Now the charged particle could also be an electron. Now when an electric field, say capital E, is applied across a material, it exerts a force on the charged particles, causing them to move with an average velocity called the drift velocity. Usually it's denoted as Vd, right? Now, mobility quantifies how effectively the electric field can push these charge carriers through the material. So when you say the mobility is high, that means that the particles can achieve a high drift velocity even with a small electric field. And conversely, when you say the mobility is low, it indicates that the particles are struggling to move due to scattering from impurities, lattice vibrations, or other imperfections within the material. So again, what did I say? I said that high mobility means that the particles can achieve a high drift velocity even with a small electric field. So that would give you a hint about the mathematical formula. So mu is high when it can be written as Vd upon E. So Vd is drift velocity and E is in the denominator, because what we are saying is the high drift velocity even with a small electric field is achieved. That means mobility is very high. So mu is V upon E. And to talk about its units, it will be meter square per volt second, or the factors that affect mobility. Now, the type of the material, the temperature or concentration of impurity, doping, or crystal structure of the material, and presence of other charge carriers are some of the factors that can affect the value of mobility. And it is a critical parameter in determining the electrical conductivity of a material. So usually electrical conductivity is denoted as sigma, and sigma is given as n into the magnitude of charge into mobility. So if the magnitude of charge is q, sigma is q mu. Or if electric charge is denoted as by E, then sigma is Ne mu, where sigma is the conductivity, N is the charge carrier density, Q or small e, whatever is the case, it is the absolute value of the charge of each carrier, and mu is the mobility of the charge carriers. So as you can clearly see, a higher mobility is going to contribute to higher conductivity for a given charge carrier density. So, and it is logical as well, right? So when you're talking about conductivity, if the mobility is high, it will result into higher conductivity. So it is very important when you are concerned with the performance of electronic devices, especially those made from semiconductors. So for example, transistors with higher carrier mobility are able to operate faster. So in a nutshell, mobility is a measure of how effectively charge carriers move through a material under the influence of an electric field. And it's a fundamental property. It dictates the electrical behavior of materials, and so it's very important when you are trying to design electronic devices. Thank you.